Mili Trivedi from LJ Institute of Engineering and Technology, and as we know that we are covering the dynamics of machinery theories as well as numericals. So this is our last topic of balancing chapter, and the name of the topic is balancing machines. Now students, balancing machines are widely used in so many industries, and as we all know, we have already know about our wheel balancing equipment. So if you don't know anything about your wheel balancing equipment, you have to go at any garage or any service station and you can have and check it. Okay, so this kind of balancing machines were widely used in mechanical industries to balance the system. Okay, so here in our case we are only covering three basic type of balancing machines which are widely used in engineering, particularly in industrial point of view. Now first of all, our topic is of static balancing machine. So here static balancing machine, we are as we see in our diagram, that it is just like the weighing machine type of balancing machine. So with the help of the weight, we can balance any of the system. Now as we all know, in the balancing system, what we often do, so we often balance our system as the mass balancing system. We need to balance the masses only. Okay, so now in our case, let us balance the masses. For mass balancing system, what we have to do, so there is a support. On the support, there is a lever. The lever, which is known as a beam. At one side of that beam, we have to put the weight. Weight should be of exactly of the opposite side of weight. It means just like we need to balance the mass of a system. Okay, so whatever the weight at the right hand side, we have to put it at the left hand side. Okay, so here we are having the masses. So right hand side is equal to left hand side. Both the masses should be similar. Now as we all know, in our system, because we are making so many products with the with our casting system or any other system, with respect to any defect, the CG of that system will may deflected. And as we all know, if CG is deflected, the mass center is not exactly at the midpoint. Okay, it will be vary at right hand side or left hand side or slightly upward or downward. So that we have to put our mass on the other side of the weight. Okay, and then we will give us the slight rotation to our system. Now by giving the manual rotation to the system, by the deflection of its CG, the pointer will give us the exact value how much it is deflected towards right hand side, towards down side or towards left side. Okay, and by this, by continuously trial and error method, we can easily find out how much the system can be balanced manually. Students, this is originally the manual balancing system. Okay, so it is known as pendulum type static balancing machine. Okay, so if any object is having very thin thickness, so that we can balance that kind of object in this system. Clear? Now let us have next topic, which is cradle type balancing machine. So here in the cradle type balancing machine, as you see, the motor and the rotating part both are mounted on a cradle. Okay, hence the name is cradle type balancing machine. Now this cradle is mounted on a foundation. Now between the cradle and the foundation, we are having two pivots as well as two springs. So as you see in the diagram, from the front view, you only you can see single spring, but originally the single spring at the front side, and because of the width of a cradle, front side is a spring as well as back side there is also a spring. Okay, so that we are having two springs as you see in our side view. So we are having two springs. Okay, now and also two pivots for the balance of the system. Now with respect to the motor, we need to rotate the part. In this case, we can have some major parts like flywheel, okay, and turbine, which are using in day-to-day life. We can balance that kind of part also. Now, in this case, it is also the cradle type balancing machine, so that it is not exactly the static balancing machine, but it will oscillate slightly. Hence, we can say it is just like the static balancing machine. We only need to balance the forces, not the couples. Clear? Now, if rotating mass will rotate at certain speed, the effect of that rotating mass will be on the shaft. Okay, and with respect to that shaft which is attached at the cradle will sway, and by that effect we can find out how much value we need to balance. Okay, so this is the simplest type of cradle type balance machine. This will use as a wheel balancing machine. Now, what do we do in a wheel balancing machine? We have to put some milligram weight, or we need to reduce it. As you see in so many wheels, if balancing takes place, then we have some minor masses on that system, so that we can balance it in mg, milligram masses. Okay, now this is our cradle type balancing machine, which is used in day-to-day life for the industrial point of view. Now let us have the dynamic balancing machine. Now this machine is also known as pivoted cradle type machine. Now why this name is like so, we will see and discuss in our session. Now let us have, there is a giant mass like giant flywheel or giant compressor or giant shaft. Okay, so if we are having giant turbines, we can use the giant machines, the balancing of the giant machine in the dynamic balancing machine. Now why we are using giant machineries and the balancing of giant machineries on dynamic balance? Because if the machine is giant, it is having the larger width, and having the larger width will give us some amount of different planes value. It means if mass is variable, we are getting the different values of imbalance masses at different planes. Hence, we have to study at different planes, so that we have to consider the dynamic balancing machine. Now, as the name suggests, we can understand that because it is the dynamic balancing machine, it will balance the forces as well as the couples which are generated with respect to the system. So, let us have, first of all, we need to put the whole mass on the cradle, and that cradle is having the support. Okay, and there is a rolling shaft. So the shaft is rigidly mounted on our rotating object. Our rotating object is rigidly mounted on the shaft. Shaft is having some sort of balancing or some sort of support only towards the cradle. Now this cradle is having two amplitudes. One is the left hand side amplitude, and another one is the right hand side amplitude. Okay. Now this amplitude, what is the working of this amplitude? Now let us understand. Left and right side amplitudes are mounted on spring as well as damper. Okay. Now by the motor with the universal coupling, the shaft is rotated. When the shaft is rotating, with the help of that shaft movement, the whole big part will also move. Now, they are trying to rise the speed of the shaft. By rising the speed, what will happen? The effect of the forces, imbalance forces, as well as couples, will be on the cradle. And the cradle is mounted on spring and damper, so that it will sway severely. Okay. Now, it is having two pivot. One is the locked pivot, and second one is the free or released pivot. Now, locked pivot will lock itself. It means it will represent as a reference plane. Now, released pivot will give us the exact value of that particular portion, if it is balanced or not. Okay. So here we have to, first of all, we have to lock one side of pivot. Let us say right side pivot we have to lock. Then we have to move our released pivot point by point or place by place. And then we can get the values how much amplitude, by how much amplitude the system is imbalanced, and that amplitude is measured in left side indicator, amplitude indicator. And what is that amplitude indicator indicate? The amplitude of the motion. It means the displacement x. Okay. Now, then after that we have to lock the left hand side pivot. And by locking that left hand side pivot, we have to move our right hand side pivot, and we'll get the different values at different points. Okay. And all that things are mentioned or measured in the right side amplitude indicator, as well as it will also give us the amplitude value. It means the displacement value, right? By that calculation and by the help of the advanced system, we can directly measure that if the mass should be added or removed. Okay. Now, if we need to add some mass, then what we have to do? We have to put that particular mass on a particular position in x, y or z direction, on a particular position, and we need to fix it. Okay. It is not like the magnetic mass we need to put. We have to fix the mass by nut and bolt because they are giant wheels. Okay. And if we want to remove the mass, then what we have to do? We have to drill it out and remove the mass as it is. Okay, because they are giant wheels, and because they are like this, we cannot make and melt and again do casting and everything, you know. Hence, we have to just remove and add the mass according to our requirement. Clear? So this is the dynamic balancing machine, which is very, very, very important for the designing and balancing of flywheel or Pelton wheel turbine or Kaplan turbine or any other turbine you have studied in your previous subjects. So it is just like this. If you have any query, you can ask me. This topic is very, very, very easy. If you read it once, you will get it. And in so many books, it is elaborated very well. Okay. Thank you.